Now, let us discuss the another important topic about the memory layout and its impact in the performance of the any computing device. If you see carefully, so there are many programming languages these days, but all programming languages use some kind of order to store the data in the memory. So, generally the programming languages may use either row measure order to store the elements by default or column measure order to store the elements by default. So, you can say that there are either row measure order or column measure order, either one of it are followed by the programming language to store the elements in the memory. So, if we see the MATLAB, Fortran, Julia or R, these are the popular programming languages. They store the matrices in column measure order by default. But if we see the Python and its library like Panda use the column measure order layout for storing the data frames. Now, other programming languages like C, C++, Java and Python and library like NumPy prefer row measure order layout by default to store the elements in the memory. So, now I will just focus on what is row measure and what is column measure order and what its concept. So, first before going to discuss in detail about this concept, I would like to stress here about the memory. Memory is always the unidimensional. Memory is not like 2 dimensional or 3 dimensional. Memory is always a unidimensional, means where memory at start at particular location and increase serially to the highest available location. And if I am talking about the matrices of 2D or 3D matrix, so these all are the concept of program or software concept, or you can say the multi-dimensional array are the software concept, and these multi-dimensional arrays are to be stored in the memory, and then these elements multi-dimensional arrays will also be stored in a memory in a sequential order. Suppose you want to store a matrix which is given here and you are using any programming language that's by default supports the row measure order, then elements will be stored. First row will be stored and then second row and then third row will be stored. You can see I have mentioned the arrows how this element will be stored in a unidimensional memory. In case you are using any programming language and that supports the column measure order by default, then the data elements will be stored in a column wise. You can see the arrow I have mentioned. So, now I will discuss how the 1D row is stored in memory space. Suppose you are following the language which supports a row measure order. So, in a first array the elements are A1 to A9, they are going to store first, I am just assuming. So, they are storing in a continuous memory location. Here M0, M1, M2, all these M are representing the memory and number associated with that is representing its location. Similarly, if we want to store 1D array of second row these elements. So, where the first will close, then very next memory location this element will start getting stored in a continuously. And this will happen whether you are using any language that supports whether row measure order or column measure order, because the data you are storing that is of one dimensional only. Now, we are storing the two array and they are declared in this manner. First one is a row manner and another array is declared in a column manner, and you are using the language which supports a row measure order. So, you can see that how the data is going to place in the memory locations. It are continuously from memory 0 to memory 8, all elements are getting stored. Memory 0 here and memory 8 is here. So, elements A 1 to A 9 is getting stored in this locations, you can see continuously. Where this memory ends for the 1D row, then another array which are defined in a column order. So, they will start storing the elements continuously in a continuous memory location, and this will happen whether you are using the language which supports row measure or column measure. There is no difference, you can see the previous example, and in this case you just see how the elements are stored in memory location for two array which are declared in a row form or you can say horizontally. And in this case you can see that I am using again define the two arrays, one is a row wise and another one is a column wise. And when we look at how they are getting stored in the memory location, there is no change in two cases whether I am using row measure or column measure. But when you start dealing with a 2D matrix or 3D, the difference starts affecting when you start storing the elements in the memory. Suppose this is a 2D matrix, we have a 9 elements and you want to store, and you are using the programming language that supports by default row measure order. So, you can see that the first row is going to store first is a first row, after that the second row is going to store next, and after that the next row is going to store. It happens in a row measure order. And then you can see how they are getting stored in continuous memory location. But if you are supporting any language that supports the column measure order, then you can see that how these elements are getting stored in a continuous memory location. So, this is the difference comes in 1D array, there is no difference, but when you start dealing with above 1D like 2D or 3D, then the impact of memory location will start impacting the performance as well as because start impacting the performance because of the way the elements are being stored and how you are fetching this element. I will discuss it in next slide. So, before proceeding further, so I will just give you some sort of practice, so that you could develop your understanding about the row measure order and column measure order. When you are following, when you have two matrices of 3 by 3, 3 by 3 and you want to store in this memory locations, then how they are going to store? You are using the row measure concept, means language you are supporting that is supports the row measure order only. So, here you can see that here it is going to A1, A2, A3, A4, A5, A6, A7, A8, A9, and when it will be stored, then second matrix will be going to store here, order will be B1, B2, B3, B4, B5, B6, B7, B8, and here it will store B9. This way the two matrix will store in the memory locations if you are using the row measure concept. Now, let us discuss how these two matrix is going to store in the memory if you are using the column measure order. So, here you can see that A1, A4, A7, A2, A5, A8, A3, A6 and A9. It is going to be A9. This way this will store the first 2D matrix, and next it is going to store B1, B4, B7, B2, B5, B8, B3, B6 and B9. So, I hope we have this concept is clear to clear. What is the impact of row measure order and what is the impact of column measure order, and how they are going to store the matrix 2D matrix in the continuous memory location. Now, let us suppose I have to perform the matrix multiplication of two matrix. The size you know that is a 3 by 3 in size and 3 by 3 in size. When we perform the matrix multiplication, we know that the first row or row of the one matrix should be multiplied with the column of the another matrix. That is the equation. And we know that how, if I am using the row measure order, if I am using, I am writing here row measure order, and the elements are going to store in a memory is in this fashion. B5, B6, B7, B8 and B9, and I am assuming that my cache line size, I am just writing as a cache CL, cache line size is 3 byte, just assume to make the explanation simple. When it will comes to the memory location, it will take first 3 elements which is required, because we know that 3 elements is to be multiplied by the 3 elements in a column. So, cache line size is coming, it is taking the 3 elements and storing in the register, but to complete the operation it also required these 3 elements B1, B4 and B7, and it is another vector, another 2D matrix, and it is going to start here. Then the cache cycle will come and it will take these 3 first from the second matrix, and it will find that it is expecting B1, B4 and B7, but it has only the element that is required is B1 is available, other 2 is not of use for this particular operation. And then cache line size will again come in a second cache line size, it will carry the next 3 elements. When it will carry it again find that only B4 is of use and others are not of use, and next cycle it will carry this next 3 elements, and it will find that B 7 is of use and other elements are not of use for this particular operation, when the first row is going to multiply with the first column of the second matrix. So, that means the 3 cache line cycles are required to get the complete data which is required to perform the particular operation. So, definitely it is going to degrade the performance, and we can say this is a misaligned access of the memory, and second I can say data is not arranged in a coalesced manner. Because of this matrix multiplication is going to give a degraded performance. Then what is the solution we can think it of? So, what we have to think is that how we can get this data B 1, B 4 and B 3. So, what we can do? We can transpose this matrix, and software we have a matrix, we want to perform the matrix multiplication. When one row has to multiply with the column of the another matrix, when it is going to store in the memory, they are not properly in a coalesced manner. But if we transpose that, then what is going to happen? It is going to B 1, B 4, B 7, B 2, B 5, B 8, it is going to B 3, B 6 and B 9. And now, if I store, after transposing, if I store this matrix in a memory location, then how it is going to be stored? Just see. It is B 1, B 4, B 7, B 2, B 5, B 8, B 3, B 6 and last one is B 9. Now, when the first cache line will come, it is carrying the first 3 elements of the first row of the matrix 1, and in second cache line will come and it will carry this 3 elements, and all the required 3 elements is the cache line is carrying in a one go, B 1, B 4 and B 7, which is required to perform the matrix multiplication. So, this way the data is arranged in a coalesced manner. When data is arranged in a coalesced manner, the memory cycle, memory transition has been reduced. Earlier case we are required 3 memory transitions, but now it is only 1 transition is required and data will be available in the registers. So, this way the small modification in the program can improve the performance, but it is always important to understand how the data is being stored in memory locations by the chosen or by the any programming language which you are using to develop your application. Now, I will discuss another topic. I will not going to discuss this topic in detail, but I just want to give you the idea about the Python Numba programming, and this Numba library is also used to program the NVIDIA GPUs. So, with Numba, developer can write the kernel directly with a subset of Python, and the Numba will compile the code on the fly and run it on the GPU. But Numba is not only the option that are available to program the underlying GPU. The community has developed different libraries to program the GPUs, just like CUPy, which offers high level functionality, which rely on the CUDA under the hood, and low level CUDA support for integrating the kernels written in C and JIT enabled Python functions as well. PyCUDA is another library which also provides even more fine grained control over the control of the CUDA APIs. In the same line, NVIDIA also has released their official CUDA Python, because it is this is developed by released by the NVIDIA itself, vendor itself. So, surely it will have a more functionality as compared to the other. Now, so how to install the Numba, how to work with Numba in your machine. So, first of all, you must have a Python must be installed in your environment or on your machine, and after that you have to install the Numba. There are various ways to install the Numba and configure the Numba on your machine. You can use pip install, or you can install Numba from the source. Once this Numba is installed and it is configured properly on the system, you can run this command. And another important thing is that if you want to run as a .py file, you can run it. If you want to run use Jupyter Notebook, it will support the Jupyter Notebook as well. So, suppose you are using any Jupyter Notebook, and if you run this command CUDA.detect, and it will detect, if it is properly configured, and it will detect the underlying GPUs and give the information about the GPUs that are available on the environment. If it is throwing error, that means your Numba is not configured properly. So, before proceeding further, it is always important your Numba should be configured properly on the underlying system. Now, you can see we have written a very small program just to check the which version of Numba or NumPy is available in a particular system we are using. So, for that you have to import NumPy as NP, and you have to import Numba libraries, and from Numba you have to further import the CUDA libraries, and then you can just check the version. If these two is printing the giving the output with the version number, so then you can say that it is properly installed and configured. Now, in terms of GPU programming, I will discuss the most important point, that is a decorator, the JIT decorator and CUDA.JIT decorator, and these two decorators is provided by the Numba. When I am talking about the JIT, JIT is a JIT in time compiler that translates the subset, important thing is subset of the Python and NumPy code into the fastest machine code. So, whenever I am stressing the word the subset, that means wherever or whenever JIT decorator is applied to any function, only that particular function is going to be compiled into the fast machine code. So, you can see that for this addition function I have applied the JIT. So, this code, this addition function will be compiled to the fastest code. Numba compiles the functions just in time into the efficient native codes, and this code still run on the CPU more effectively than the GPU. So, this code belongs to the CPU. Now, I will discuss the another decorator that I have mentioned here. You can see at CUDA.JIT. whenever we are applying this decorator to any function. So, that is indicating that this function is a CUDA function and this function will run on the GPU or execute on the GPU. Now, the another important thing is this portion of the code. As we have already discussed in a C program, we have to, whenever we are using NVIDIA GPUs, so we have to define the threads per block and the blocks per grid. These two parameters are very important to pass to the NVIDIA GPUs. And after that, these two parameter is to be passed to the kernel function, which we have declared above here with the CUDA.JIT decorator. So, in C programming we were using triple angular bracket to pass the two parameters like blocks per grid and threads per block. NumPy is using this brackets, you can see NumPy is using this square brackets, and within these brackets it is also passing these parameters in the same order, blocks per grid and threads per block. After that, they are passing the, if the inputs, what are the attribute is to be passed to this function, we have to apply here. So, if you see the structure of the program is almost same, just like in C, only the few changes we have to apply in a NumPy by using just like a JIT or CUDA.JIT decorator. So, this is a small idea I have given you, but if you see that NumPy programming for NVIDIA GPU is a complete course altogether. So, there are various website links or GitHub links are available on internet. Learners can use those resources to gain the expertise on the NumPy programming. Now, I will discuss few functions that NumPy basically provides us. Just like in a C CUDA programming model, it provides some functionality. Similarly, NumPy is also provides some functionalities like NumPy.CUDA.device underscore array, this is one of the function. So, what it does? It creates an uninitialized array. So, earlier we are using a CUDA allocate in C to declare some array or space in the memory. So, similarly, this functionality, the same role is being played by this function which is provided by the NumPy. It is used to allocate the memory on the CPU for storing the array that will be populated or used during the kernel execution. Suppose we have a two array, array B and array B, and you want to declare the memory locations for that. So, in that scenario you have to launch two CUDA malloc functions two times for two arrays, but here I can use this array if I want to create an array of same size of same type. So, I can just use this function with underscore like. So, it is what it is doing, it is creating a new device array with the same shape and type as the existing array. Next function is that CUDA NumPy.CUDA.thread index. It provides the thread index within the current block. Suppose, as we know that within a block there is a number of threads. If you want the index of the thread within a block, so you have to pass this function, and it is used to identify the position of the thread within a block in CUDA kernel. Similarly, there is another function is called NumPy.CUDA.blockIDX. It provides a block index within a grid. The same block IDX keyword we have used in CUDA programming model, and this is used to identify the position of the block within a grid. Now, numba.CUDA.grid, you can see this function. This function computes the unique global index of the thread within the entire grid. This functionality is not available in a CUDA programming model, where there we have to calculate this unique ID by deriving some formula for 1D, 2D and 3D, but Numba does work for you with a small one function only. Next function is a CUDA numba.CUDA.blockDim, which provides a dimension of the block used to determine the size of each block in terms of number of threads, and another is the numba.CUDA.gridDim. This function, it provides, the name itself is suggesting, it provides a dimension of the grid, number of blocks within a grid. Next function, numba.CUDA.gridSize, it calculates the total number of threads in the grid. In earlier case, we have to do some mathematical computations, we have to multiply the number of threads in x direction, y direction and z direction, but here with the same function, with single function, it is going to give you the answer. Next is a synchronization function is also there, as we discussed the various synchronization function. So, Numba is also provides some synchronization functionality. So, it blocks the host until all the threads in the GPU have completed their execution. So, you can say that it is a kind of device level synchronization it is providing. It ensures that all the GPU operations are finished before proceeding in the host code. So, it is important for synchronizing and avoiding the race condition. So, likewise, you can refer various online resources and you can study more functionality, such kind of functionality which is provided by the Numba to develop your programs. In a next session, I am going to discuss the few programs and we will demonstrate you how to execute those programs by taking the GPU interactively and how to execute the program with the help of Slum scheduler, with the help of using or you can say that using the Slum script. So, in interactive mode we always have to specifically we have to put the request and what GPU resources will be allocated to the user for a particular time being. But if we use a Slum and Slum script, then the Slum will take care, Slum is a scheduler, it will take care of the resources, whichever the free resources will be available, it automatically allocate to you and execute the programs accordingly. So, all these things, execution of the program, accessing of the cluster and performance of various logics which we have discussed in throughout this theoretical session will be discussed in this lab experiment programs. Thank you.